All right, in this video, we're going to be looking at how to add fractions, how to add rational expressions. So remember, when you're adding fractions, you always have to have a common denominator. So with these first couple of examples, that's what we're going to be working with. We're going to be working with scenarios where we already have a common denominator. So if you already know what the common denominator is, remember that means that the denominators can remain that same denominator. So in this case, our denominator is going to remain x plus 4. In our numerator, we're just going to add together those two pieces. Now we can't actually add x plus 5 and get, so don't write 5x, that would be wrong. X plus 5 would be our numerator, x plus 5 over x plus 4. And that would be our answer. Now remember, when we work with rational expressions, we always want to identify what x can't equal. And so in this case, x can't equal, because we don't want to have a 0 in our denominator, so x can't equal negative 4. So our rational expression would simplify to be x plus 5 over x plus 4, and x can't equal negative 4. Now in this next example, the denominators don't look the same. However, remember, you always want to make sure that you start by looking to see what can factor, how we can factor the numerator and denominator. In this case, our denominator x squared plus 3x can be factored. Now you always look for a GCF first. That's always your first step. Look for a greatest common factor. So our greatest common factor in this case would just be x. Okay, both of those terms have an x, so we can factor that out. So we would have x times x plus 3, and now we can see that both of our denominators are the same, so our denominator is going to be x times x plus 3. You don't have to simplify that. You can leave it as x times x plus 3. Now our numerator, we're going to combine like terms. So 2x and 3x, we can combine those together to be 5x. And then we have a positive 1 and negative 8. We can combine those. Now 1 plus negative 8 would be negative 7. So we'd have 5x minus 7 in our numerator. Our denominator is x times x plus 3. Now remember, we want to list out what x can't equal. So we set each of those factors equal to 0 and solve it. So one of those solutions would be 0. So x can't equal 0, and the other would be negative 3. So those would be our answers for that one. All right, I want you guys to do the same thing for this next one. So I want you guys to add these two fractions and then also identify the values that x can't equal. So go ahead and pause the video and hit play when you're ready to check your answer. All right, let's see how you did. So this one, we already can see the denominator is going to be 2x plus 3. So in the numerator, be careful. So you want to combine like terms. So the 10x and the negative 4x is what we would combine there for the variable. So 10x minus 4x would be 6x. And then for the constants, we have negative 5 and a positive 8. So when we add those together, negative 5 plus 8 would be a positive 3. And that can't be simplified at all. When it says simplify, if you were to look at the numerator, yeah, you could factor out a 3. And so we'd have 2x plus 1, but that wouldn't do anything to help us. So we're just going to leave it like this. And the only other thing that we would do is we would say what x can't equal. X can't equal negative 3 halves. So if you set 2x plus 3 equal to 0, your answer wouldn't be negative 3. We would subtract 3, but we also have to divide by 2 to get 0. So negative 3 halves would be our restriction there. All right. Now those are pretty basic. That's when the denominators are the same. But what if they aren't the same? So if they aren't the same, we're going to have to find what we call the least common multiple. If you use the word least common denominator, I'd accept that as well. But the least common multiple, let's say if we have these two denominators, let's say if we have a denominator of x plus 2, and x plus 3, or even look at it as x plus 2 squared. So if you have x plus 2 squared, I would recommend recognizing that's the same as x plus 2 times x plus 2. But let's say if we have x plus 2, and x plus 3 as our factors in one denominator, and x plus 2 and x plus 5 in our other denominator. Our LCM, our least common multiple, or least common denominator, however you want to look at it, in that first denominator, we would have x plus 2 times x plus 2, or x plus 2 squared. And then we would also have x plus 3. So we would want to include that one. So what I always do is I always start with one of the denominators, look to see what all we have from that one denominator. And in the other denominator, let's say if we have this in our denominator, x plus 2 and x plus 5. Now x plus 2 is already represented here, so I don't need to write it down again. But x plus 5 isn't listed, so we're going to have to list that out as well, or add that to the list as well. So this would be our LCM, our least common denominator. or if we wrote it as x plus 2 quantity squared times x plus 3 times x plus 5, it would mean the same thing. So that's always going to be our first step when we're dealing with fractions with an uncommon denominator. So let's look at this. Let's say if we have 10x squared minus 10, 15x squared minus 30x plus 15, and x squared plus 3x plus 2. So let's work with each of these individually. So let's start with this first one. So this first one, I want to get these in factored form. So this first one, I can factor out a 10. And that's all I can factor out as far as my GCF. Now again, we want to make sure we factor these completely, and I recognize that x squared minus 1, that's a difference of squares. So I want to make sure that we get them completely factored. So let's look at this one. So this one, we see that every single term is divisible by 15. So if we do that, we'd have 15 times x squared minus 2x plus 1. And then let's see if that inside piece, let's see if that x squared minus 2x plus 1 can be factored. So there are two numbers that multiply together to be a positive 1 that add together to be a negative 2. Hopefully you've figured that out. That'd be negative 1, because negative 1 times negative 1 would be a positive 1, and negative 1 plus negative 1 would be negative 2. And then let's look at that last set. So that one, there is no GCF, so let's just look at factoring that down. So what two numbers multiply together to be 2 that add together to be 3? Well, that's just 1 and 2. All right, so now we got to figure out what's our LCM, our least common multiple. So what I like to do is I like to start with the 10 there for our first. By the way, the 10, if you want to look at that as being 2 times 5, that's going to help us in a second, because 15 will be the same as 3 times 5. So we can look at it that way. So in that first set, we would have, let's just write that as 2 times 5 times x plus 1 times x minus 1. Okay, so that's what we have in the first set. Now when we look at the second set, we have the 5 listed, but we don't have a 3 listed. So I'm going to put a 3 out in front there. So we have to include that. So that would be 3 times 2 times 5. And we have one x minus 1 represented, but we don't have another one. So we have to include both of them. Okay, so now we'd have 3 times 2 times 5. And then for the factors, we would have, for the algebraic factors, we'd have x plus 1, x minus 1, and another x minus 1. All right, let's go to the next one that we have in purple there. So x plus 1, that's represented, so we don't need another one of those. But x plus 2 is not represented, so we need to add an x plus 2 there. So my least common multiple, if I multiply those numbers together, 3 times 2 is 6, times 5 is 30. We could write it like that, so we'd have x minus 1 squared times x plus 2. That would be our least common multiple. All right, I want you guys to try this next one on your own. So do your best. I know it can be this is a little tricky, but I want you to do your best. At least see if you can factor these down and see what you can't get started for the LCM there. So go ahead and try this one on your own. So pause the video and hit play when you're ready to check your answer. All right, let's see how you did. So for this first one, I see that we can factor out an x, and so we'll be left with x squared minus 9. Hopefully you recognize that's a difference of squares. So that factors down to be x plus 3, x minus 3. All right, let's look at this one. So this one, there's no GCF there. So what two numbers multiply together to be negative 15 that add together to be negative 2? Well, the bigger number's got to be negative, so let's try negative 5 and positive 3. So negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. And then let's look at that last one there. So this one, we would factor out an x, and that leaves us with x minus 5. That's not a difference of squares, so that's can't do anything more with that. All right, so let's see if you got the LCM, so the least common multiple. So again, I like to start with this first bunch, so we have x times x plus 3 times x minus 3. Then I like to see what we need to add to that. So in the next set, well, I see that we have the x plus 3 already, so I don't need that again. I already have it listed once, we don't need it again. but I don't have an x minus 5, so we need to include that. Looking at the next set, I already have an x, so that's already included, and I already have an x minus 5, so there's nothing more I need to add for that one. So my LCM would be x times x plus 3 times x minus 3 times x minus 5. All right, well, why do we do that? Again, the reason why is because sometimes we're not going to have fractions with common denominators, in which case we're going to need to know what the common denominators should be, and we get that from the LCM. So let's look at what we would do in this first one. So this first one, we're going to always start by factoring. So this is a difference of squares. So that factors down to be x plus 1 times x minus 1. Same thing with this other fraction. Let's factor that down. So that would factor down to be what two numbers multiply together to be a positive 2 that add together to be a negative 3. That's going to be a negative 1 and a negative 2. All right, so now once we get that written down, we can identify what the LCM is going to be. So the LCM, let's look at that first fraction. It has a denominator of x plus 1, x minus 1. Okay, that next fraction, x minus 1, is already represented, so I don't need it again. But x minus 2 is missing, so I need to include that with my LCM. So my least common multiple, or another way to look at it, your least common denominator is going to end up being x plus 1, x minus 1, and x minus 2. It's going to be those factors. All right, so now what we're going to do is we're going to use the LCM to write each fraction with a common denominator. That's where we're at right now. So we factored each denominator. We found the LCM. We're going to use that to figure out what to write these as individual fractions with a common denominator. So that first fraction has x plus 1. It has x minus 1, but it's missing x minus 2. So we're going to multiply the top and bottom. Whoops. Forget that error there. So we're going to multiply the top and bottom by x minus 2. So when you do that, we'll just leave this right now as x minus 2 times x plus 3. Our denominator is x minus 2, x plus 1, x minus 1. Okay, now that second fraction, we're going to always compare to your LCM. So the second fraction, x minus 1, yep, we have that one. X minus 2, yep, we have that one. But we're missing now the x plus 1. So we're going to multiply the top and bottom by x plus 1. All right, so now what do? We're going to simplify the numerators. So the numerator, that first one, because the reason why we have to simplify it is because at some point here we're going to add like terms. We're going to get this as a single fraction. So you can either use a box method, or you could use this method, which means I'm just going to multiply everything by x, and then I'm going to multiply everything by negative 2. So when I multiply everything by x, I'd get x squared, and x times 3 is 3x. And then when I go to the next term, negative 2, I'm going to multiply that times x. I get negative 2x. Negative 2 times 3 is negative 6. And then over here, I'm just going to distribute the 2 through, so that become a positive 2x and a positive 2. We have our denominator. So we're going to have one single denominator that's the same. So it's going to be that same x minus 2, x plus 1, x minus 1. All right, now let's simplify the numerator. I didn't need that big of a fraction bar, so I'm just going to rewrite this. So again, the denominator is going to stay the same. The numerator now, all we have to do is combine like terms. We have an x squared. Maybe cross them out as we get done with them. Negative 2x plus 2x, that would be 0x. And then be left with 3x. And then with our constants, negative 6 plus 2 would be negative 4. As far as our process, we're on this last step. The last step, it says factor the numerator to see if the rational expression will simplify. All right, so when we look at x squared plus 3x minus 4, since we have a quadratic, we need to see, before we're done, we need to see, can that be factored down at all? Because if it can factor, there could be a possibility of being able to reduce this fraction. So we want to look to see, are there two numbers that multiply together to be negative 4 that add together to be 3? And yes, there are. So that factors down to be x plus 4, x minus 1, because 4 times negative 1 is negative 4, negative 4 plus negative 1 would be 3. And now if you notice, the x minus 1s cancel out, and leaving us with x plus 4 over our denominator, x minus 2, and x plus 1. Remember, we also have to give the restrictions what x can't be, and I intentionally waited to the end because I'm guessing a lot of you guys will forget to do this until you get to the end. So remember, to get those restrictions, we always go back to before we canceled anything out. So we look at the denominators, so we would have x can't equal 2, x can't equal -1, but also x can't equal +1. So those are the restrictions, and that's what it reduces to. All right, so I know that's a lot. Okay, so I want you guys, here's what we're going to do. I want you guys to do the first part. I want you to factor the denominators here. So just do that first part. So pause the video and look at part B here. And I want you to just factor the denominators, hit play when you're ready to see if you factor those correctly. All right, let's see how you did. So this would be x plus 2, x minus 2, because that's a difference of squares. This would end up being x minus 2, x minus 3. It's -2 times -3 is +6. -2 plus -3 is a -5. All right, so if you got that, I want you to go on to the next step. So the next step is I want you to identify what the least common multiple would be. So see if you can't figure that out on your own. So again, hit pause and then hit play when you're ready to check to see if you did it correctly. All right, let's see how you did. So your first step, what I like to do is I like to look at our first denominator. We have x plus 2, x minus 2 in our first denominator. And then I look at our second denominator. Second denominator, we already have x minus 2 listed, so I don't need it again. But I don't have the x minus 3 listed, so I need that one. All right, so hopefully you got the LCM correctly. Okay, so now let's do the next step. I want you guys to try this next piece on your own. Get this as a common denominator. Okay, so I want you to figure out what's the first fraction missing. So whatever the first fraction is missing, include that for the numerator and the denominator. Look at the second fraction. What's that one missing? And then include that one to get a common denominator. And then combine those. So if you want to, so see how far you can get this, but I'm just going to have you guys just get these so they have common denominators, and then we'll go to the next step. So go ahead, pause the video, try that next step on your own. All right, let's see what you did. So this first one, x plus 2, x minus 2, I have these two. I'm missing the x minus 3. So I'm going to multiply the top and bottom by x minus 3. Okay, go to the next fraction. The next fraction, we have x minus 2. We have x minus 3 listed, but I don't have the x plus 2. So we're going to multiply the top and bottom by x plus 2. So now, in essence, we have a common denominator. Now to save some space, because you can see that I'm running out of space here, we know what our common denominator is going to be. It's going to be that LCM of x plus 2, x minus 2, and x minus 3. So what I want you guys to do is I want you to figure out what the numerator should be, and then see if that can factor down. So go ahead, distribute, do all the distributing like we did for the previous one. So distribute by x and -3, and then distribute the 2 through, and then combine like terms, and then see if that can't be factored and simplified. So see if you can't do the rest of this on your own. All right, let's see how you did. So in the numerator, we distribute the x through, and you'd get x squared plus 6x. Distribute the -3 through, you get -3x minus 18. And the other fraction, now this is a positive 2. That's going to come into play with what we're going to learn about tomorrow. Distribute the 2 through, we get 2x plus 4. Now we're going to combine like terms. So I know what my denominator is going to be. Okay, so we're going to combine like terms. We got the x squared, there's no other x squareds. Go to our variables. 6x minus 3x, that's 3x. And 3x plus 2x is 5x. And then -18 plus 4, that's -14. All right, so then you should look to see, can that be factored? And in that numerator, what two numbers multiply together to be -14 that add together to be +5? That's going to be -7 and +2, because -7 times 2 is -14. -7 plus 2 is, oops, sorry, made a mistake. Had my negatives in the wrong spot. So it should be a -2 and a +5. There we go. Because 7 times -2 is -14, 7 plus -2 is +5. All right, now we're ready to move on. So I see that the x minus 2's cancel out. So my answer is x plus 7 in the numerator. In our denominator, we would just have x plus 2 and x minus 3. And what x can't equal? Remember, go back before I cancel them out. So we'd have -2, a +2, and a +3. Those are our restrictions for that one. All right, so that's it. So hopefully you understand how to add fractions. The biggest issue there is finding the least common multiple or the least common denominator, and then using that to get our fractions with common denominators, so that way we can add those together and simplify. So follow those steps and you will be able to do these on your own.